I got rid of more numbers here. P equals 2L plus 2W. It's not enough just to say solve this, because then the question is, solve this for what? Yeah, I'm singing it too. So if I said solve for L, then L becomes the variable. Everything else becomes a constant. We treat it just like a number. To solve this for L, we would want to get the L by itself, which means we got to get the 2L by itself, which means we would need to subtract 2W to get rid of adding 2W. So that just gives us P minus 2W equals 2L. And then to get the L by itself, we would have to get rid of times 2. So we would divide both sides by 2, and we would get that L equals P minus 2W over 2. This is called a literal equation, where instead of using numbers, we're using a bunch of different letters standing for different constants, treating only the thing we're solving for as the variable. If instead of solving for L, we had said solve for W, then W would be the variable. And we would want to get the plus 2W by itself. What's happening to that? 2L is being added. So subtract 2L. P minus 2L equals 2W. Divide both sides by 2. W equals P minus 2L over 2. So literal equations are just like regular equations. You use the same rules. So this was the formula for perimeter. We actually kind of used that earlier when we were talking about the fence. Here, by having it for W, you can plug in the perimeter and the length and get what the width should be. Or when it was solved for L, you can plug in the perimeter and the width and get what the length should be. Or in its regular form, when it's solved for P, you can plug in the length and the width and you'll find the perimeter. Literal equations, you can solve them for the variable you want to find first, and then just plug things in, as opposed to plugging in what you have first and solving afterwards. So let's say we had D equals RT. This is a formula that's going to mean distance equals rate times time. If we solve it for R, then we would divide both sides by T. So we can get R equals D over T. But if we solve it for T, then we would divide both sides by R, and D over R would give us T. So when we're solving a literal equation, it will tell us what variable to solve for. And then we just do it. Use the same rules. Get rid of things by using opposites. Here's another formula. I equals PRT. Let's solve it for T. So we want to get the T by itself. Currently, T is being multiplied by PR. So we'll divide both sides by PR. I over PR equals T. So So let's expand this to some equations that have multiple variables that don't necessarily stand for a common formula that we're going to work with. So not an interest formula or a distance formula. Let's say we just had 3x plus 2y equals 6, and we wanted to solve this for y. Well, then we want to get the y by itself. We want to get the 2y by itself because the y is trapped in there. What's happening to the 2y right now? 3x is being added to it. Not because of this plus, but because of the fact that it's not negative. The fact that this is a positive 3x means that the 3x is being added. If it was negative, then the 3x would be subtracted. How do we get rid of adding 3x? We subtract 3x, and how do we keep it balanced? We do it to both sides. So 2y equals 6 minus 3x. Divide both sides by 2 to get the y by itself. And we have y equals 6 minus 3x over 2. Now, there are a couple different ways to write this same answer. When we see 6 minus 3x, remember, that's the same as 6 plus negative 3x. So we can add in any order. That's the same as negative 3x plus 6. So it's common practice that when we can, we write the x term first and then the constant term second. So 6 minus 3x, that's the same as minus 3x plus 6. Notice the 3x is negative, the 6 is positive. So that is a 6 being added to what? The negative 3x. Fraction rules. Look at that. This is true backwards, so this must be how we split it up. Common denominator, when we add on the top, keep the denominator. So this actually means we're dividing each of these by 2 separately. It is 2 separate terms because it is 2 terms on top. Three over 2, we can't do anything there. When there's an x on top of a fraction, we can push it off so it's kind of floating off on the side. And then 6 over 2 is 3. So these are 3 different ways to write that same answer. All of them are equally correct. It just depends on how far you take it. Let's do another one just like this. (4x plus 3y equals 12. We're going to solve this for y. To get the y by itself, we got to get the 3y by itself. To get rid of plus 4x, we would subtract 4x. So 3y equals 12 minus 4x. Divide both sides by 3. That means y equals 12 minus 4x over 3. And I could also write that as negative 4x plus 12 over 3, which I can also write as negative 4/3 x plus 4. So there's the 3 forms the answer could be. Where'd that 4 come from? Where'd the 3 go? Well, plus 12 divided by 3, because remember we split it. This would be negative 4x over 3 plus 12 over 3. That one doesn't reduce, but we can knock the x off. 12 over 3 does become positive 4. Okay, so that's a bit about literal equations. I will do one more in this group next time we run through this. I'll do some extra examples. A equals 1/2 h times the quantity big B plus little b. And let's solve for big B. Okay, well, the big B is currently trapped in this set of parentheses. We're going to go ahead and get that by itself. So we've got to get rid of multiplying by 1/2 h. Let's do it piece by piece so we don't overly confuse ourselves. Let's divide by the h first. So a over h equals 1/2 times, in parentheses, big B plus little b. And we can multiply by 2 over 1. Dividing by 1/2 is the same as multiplying by the reciprocal. Multiply these together, that's 2a over h equals big B plus little b. To get the big B by itself, we would have to subtract little b. Notice it doesn't get subtracted from the top, it gets subtracted from the whole thing. This is a piece. That piece, we would subtract b from both sides. Gets the big B by itself. So 2 big A over h minus little b. Okay, I said we'd get back to word problems before we were done here, and we will finish a little bit early. Negative 3 times the difference of a number and 4 equals the opposite of the number. So right off the bat, for the number, let's use x. X equals a number. And let's translate. -3 times the difference. So -3 is going to be multiplied by a difference. The difference of what? A number and 4. Equals, not so bad, the opposite of the number. Find the number. So this is our first foray into using a word problem, translating it into algebra, and then getting the answer with algebra. We do a direct translation like I showed, and then we solve. So -3 gets distributed. That's -3x plus 12. -3 times -4 equals -x. I'm going to go ahead and add x to both sides. Well, you know what? Normally I do that. But that's going to be a lot of moving here. We only have a 12 on this side. So let me add 3x to both sides. Let me drive home that fact. Like I said, it doesn't matter what side your x is on as long as they're all on one side and there's none of them on the other. Because that'll give us 12 on the left. -1 plus 3 is +2. That's 2x. Divide both sides by 2. The number is 6. Let's do one more of these. We'll call it a day. Five times the sum of a number and 3 equals 7 more than the number. Find the number. So let's just go and do a translation again. 5 times the sum. So 5 is being multiplied by a sum. The sum of what? A number and 3. Equals 7 more than, so plus 7. 7 more than what? The number. Let's solve. (5x plus 15) equals x plus 7. Go ahead and subtract x from both sides. Get it all on one side. Gone from the right. Leaves us with 4x plus 15 equals 7. Subtract 15. Leaves us with 4x. 7 minus 15 is -8. Divide both sides by 4. The number is -2. Because When we divide both sides by 4, we get x equals negative 8 divided by positive 4, negative 2. In example 3, we have twice a number plus 3 is the same as the number minus 6. Twice a number plus 3 is 2x plus 3. Is the same as is telling us equals. Equals means is the same as. The number minus 6 would be x minus 6. So if we put that all together, twice a number plus 3 is the same as the number minus 6. 2x plus 3 equals x minus 6. This time we're going to go ahead and we're actually going to find what this unknown number is. So the first step is building our sentence, building our equation. Once we've done that, we want to get the x's all on one side. So let's subtract x from both sides. Subtracting x from both sides and simplifying on the left, 2x minus x is x plus 3. I should say 2x minus x is x, and then we have our plus 3 carried over. On the right, x minus x cancels away, leaving us with just negative 6. So x plus 3 equals negative 6. We want to get the x by itself. So we want to get rid of adding 3. We do that by subtracting 3 from both sides. The 3 minus 3 cancels, leaving us with just x on the left, and then negative 6 minus 3 is negative 9. So when we have twice the number plus 3 is the same as the number minus 6, we have found the number to be negative 9. The distance by road from Chicago, Illinois to Los Angeles, California is 1,091 miles more than the distance from Chicago to Boston, Massachusetts. If the total of these two distances is 3,017 miles, find the distance from Chicago to Boston. So we have to let our variable x represent something. And we want it to represent the answer to our question. The question is find the distance from Chicago to Boston. So we're going to let x equal that distance from Chicago to Boston. We're also told that Chicago to LA is 1,091 miles more than Chicago to Boston. So it's 1,091 miles more than x. X plus 1,091 would be the distance from Chicago to Los Angeles. The total of these two distances gives us the total miles. And we're told that the total of these two distances is 3,017. So x is the first distance plus x plus 1,091 equals 3,017. Let's carry this over to the next page. Combine like terms. X plus x is 2x. We have 2x plus 1,091 equals 3,017. We're going to go ahead and subtract the 1,091 from both sides. That leaves us with 2x on the left. 3,017 minus 1,091 is 1,926. Divide both sides by 2 to get rid of the 2 times x. We want the x by itself. So x equals 963. That's 1926 divided by 2. When we're doing word problems, we always are able to check by taking our answer and plugging it back in to the original equation. And if we do plug 963 back in for x, we get 3,017. So it does check. That means the distance from Chicago to Boston is 963 miles. Let's look at another. Example 5, a woman's $57,000 estate is to be divided so that her husband receives twice as much as her son. How much will each receive? So we need to find the answers for both. Since the problem says twice as much as her son, and we don't know what the son is, that means what the son gets is going to be the unknown. We're going to let X equal the son. The husband receives twice as much as the son, twice as much as X, twice X, 2X, 2 times X. So we're going to let 2X be the husband. If we add both of these together, we would get the total $57,000. So X plus 2X equals 57,000. Combine like terms on the left. 1X plus 2X is 3X. 3X equals 57,000. To get the X by itself, we need to get rid of multiplying by 3. So we divide both sides by 3. 57,000 divided by 3 is 19,000. If we plug 19,000 back in for X, it does check. We do need to know how much the husband receives as well. So once we know that it checks, 2 times X is the husband, 2 times 19,000 is 38,000. Okay, so that was solving some application problems using algebra. Now let's look specifically at how we would solve percent problems using equations. So recognizing keywords in a percent problem is helpful in writing the problem as an equation. This should be words. 3 key words in the statement of percent problems and their meaning are as follows. So we always want to know in percent problems that of means multiplication. So times. Is means equals. And some form of what will mean the unknown number. So what does this mean? Let's look at an example. Translate to an equation. 15 is what percent of 20? Each of these gives us a different part of the equation. 15 is 15. Remember, is always means equals. What percent is going to be our unknown? We're going to call that n instead of x in this example. But x is perfectly fine as well. Of means multiply, and 20 means 20. So this literally means 15 is what percent of 20? Let's do another. 2.4 is 25% of what number? Now, when we have one of these, the first step is never going to change. The first step is always is becomes equals, of becomes multiplication. Some form of what, in this case, what number, in the last example, it was what percent, is our unknown, is our variable. What number becomes n, and the numbers carry through.
Now, when we go on to solve these in future examples, we're going to make another change, and that 25% is going to have to be written as a decimal. It would become 0.25, but we're not there yet. Let's look at another example. Translate to an equation. What number is 50% of 0.6? Go ahead and see if you can do this one. We're not solving for the number, we're just writing it as an equation. So, as always, what number becomes our variable, becomes n. Is means equals, of means multiply. N equals 50% times 0.06, or n equals 0.5 times 0.06. More practice. 3 more. If you want to try these, go ahead, pause, try them on your own, and then play and see what I do. In A, 42% of 50 is what number? 42% times 50 equals n. Of is multiply, is equal. What number is n or x? Or any variable you want, actually, because you're building this equation. And it doesn't specify in the directions what variable to use, which means it's up to you. But if it had said use n to represent the number, then you would have to use n. If it said use x to represent the number, you would have to use x. B, 15% of what number is 6? Sorry, is 9. Upside down dyslexia. Sure, 15% times n equals 9. Of is multiply. What number is n? Is equals. Everything else, the 15% and the 9 carry through. C, what percent of 150 is 90? What percent becomes n? Of becomes multiply. 150 stays 150. Is becomes equals. 90 stays 90. N times 150 equals 90. Okay. So what number is 45% of 80? We start by making our changes into an algebraic sentence, into an equation. And why is it an equation? Because is means equals, and equals is an equation. If there was no equals, it would be an expression. So what number, n, is equals 45% of multiply 80. Now we're actually going to go ahead and find this number. So remember what I said, 45% now needs to be changed to a decimal. So 45% becomes 0.45. Why do we change it to a decimal? Well, because we need to do math with it. Percents need to be decimals before we can multiply. 0.45 times 80 is 36. So n equals 36. 36 is 45% of 80. Let's do another. If you want to try this on your own, go ahead and pause. You're welcome to. First step, take what we have, translate it to an equation. 65% stays 65% of its multiply is equals what number is n? The 90 stayed 90. Next step, since we're going to go ahead and find the number, we need to do math. 65% must become 0.65. And then 0.65 times 90 is 58.5. So n is 58.5. %15 of what number is 1.2? %15 times n equals 1.2 of this multiply is equal. What number is n? First step in solving, take our percent, change it to a decimal. 0.15 times n equals 1.2. And this time, our numbers aren't on the same side. We can't just multiply with the calculator. We have to get n by itself, which means we need to get rid of timesing by 0.15. We get rid of multiplying with dividing. So we divide both sides by 0.15. We get that n is whatever 1.2 divided by 0.15 is, and our calculator tells us that it is 8. Again, $27 is 4.5% of what number? We need to make our translation. 27 equals 4.5% times n. I'm a broken record at this point, but is equals. Of is multiply. What number is n? Now, 4.5% would be 4.5%. So as a decimal, that's 0.045. We start with our decimal point between the 4 and the 5. We move the decimal point 2 places to the left to get our decimal, 0.045. We need to get rid of multiplying by 0.045. And when we divide both sides by 0.045, we get n equals 600. In example 11, we're asked what percent. Now, when we have problems that say what percent, there's one extra thing we're going to have to do at the end of the problem. Remember, when we're doing our work, we change percents to decimals. So at the end, when we get our decimal answer, we're going to have to change that back to a percent. In the other examples, it asked what number. But when it asks what percent, we need to change it back to a percent at the end. So let's not forget that. But up until that new last step, nothing here is different. Step 1, take what we have, translate it. What percent is n? Of is multiply. 35 stays 35, is becomes equals. 21 stays 21. We have n times 35 equals 21. We want to undo multiplying by 35 to get the n by itself. We undo multiplying by 35 with dividing by 35. When we divide 21 by 35, we get 0.6. 0.6 would be the decimal equivalent of our answer because all the work happens with decimals. So we need to change 0.6 back to a percent. 60% of 35 is 21, not 0.6%. 0.6 is not a percent. It's decimal that we found by doing our work. It's got to change to a percent to answer the question of what percent. You want to try this one on your own, example 12, go ahead and pause. Come back, see how you did. $35 is what percent of 25? Is becomes equals. What percent becomes n? Of becomes multiply. And we get 35 equals n times 25. We want to get the n by itself. We need to undo multiplying by 25. We do that by dividing both sides by 25. And 35 divided by 25, our calculator tells us, is 1.4. We have to change 1.4 to a percent to answer the question of what percent. Decimal place is going to go 2 to the right. So 140%. Let's look at some applications of percent. For example, wages. %18 of Frank's wages are withheld for income tax. Find the amount withheld from Frank's wages of $3,680 per month. So Frank makes $3,680 per month. Good for Frank. 18% of that gets withheld. So we want to know what 18% of 3,680 is. So when we have a word problem involving percent, the first thing that we have to do is build one of these sentences that we've been working with. In this case, we want to answer the question, 18% of 3,680 is what number? Translate. %18 times of becomes times 3,680 is becomes equals what number becomes n? We can't do math like that with the percent, so the percent becomes decimal. 0.18 times 3,680 equals n. 0.18 times 3,680 is 662.4. So that is our unknown number. $662.40. were held from Frank's wages for income tax, 18%. The principal of Slidell High School counted 31 freshmen absent during a particular day. If this is 4% of the total number of freshmen, how many freshmen are there at Slidell High School? So we want to know 31 is 4% of what total number? And this says method 1. This is a little preview for you that eventually we're going to have a second method of solving these. And we'll get to that. We'll get to that. We're not even halfway done with this presentation. You want to solve this on your own, go ahead. Pause and come back. I'm going to keep going now. Translate into an algebraic sentence, aka an equation. 31 equals 4% times n. Four percent becomes 0.04. We want to get the n by itself. We want to undo multiplying by 0.04. We do that by dividing both sides by 0.04. That gets the n on its own. And the calculator tells us that 31 divided by 0.04 is 775. That means that since n is the total number of freshmen, there are 775 freshmen in the school. So wages was an example of percent problems. Attendance could be a type of percent problem. But another common percent problem is percent increase, percent decrease. To find the percent of increase, we take the amount of the increase and we divide by the original amount. And then write the answer, the quotient being an answer to a division problem, as a percent. So the amount of the increase divided by the original amount. The average soft drink size has increased from 13.1 ounces to 19.9 ounces over the past 2 decades. Find the percent increase. So first we need the amount of the increase. To find the amount of the increase, we take our big number, we subtract the small number. 19.9 minus 13.1 is 6.8. So the amount of the increase is 6.8. To find the percent of increase, we take the amount and we divide by the original. It has gone from 13.1 to 19.9, which means originally the original number was 13.1. 6.8 divided by 13.1 is 0.5191, blah, 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 blah. Convert that to a percent, we get about 51.9%. So the amount of the increase divided by the original amount. It's the same for percent decrease. The amount of the decrease divided by the original amount. It's always divided by the original amount. Then write our answer as a percent. John Smith decided to decrease the number of calories in his diet from 3,250 to 2,100. 3,250 seems like a lot of calories per day. Just throwing that out there. Find the percent decrease. So first, we need the amount of the decrease. Big minus small to find the amount. 3,250 minus 2,100 is 1,150. What do we divide by? We divide by the original amount. And originally, he was eating 3,250 calories. So 1,150 divided by 3,250 is 0.3538, blah, blah, blah. Write that as a percent, 35.4%. Now in the homework problems, it'll tell you round to 1/10 of the percent, for instance. In order to get 1/10 of a percent, we need not just the 2 past the decimal point. That'll tell us whole percent. We need 4, because we need to look at this value 8 to determine that the 3 rounds up to a 4. And we get 35.4%. If it had asked for nearest 100th of a percent, we would need 1 more digit on the decimal to look at to get us to 2 past the decimal point in the percent. Okay, now let's take a look at some examples involving sales tax, commission, and discount. This might look confusing at first, but then you remember, I live in a society. I buy things all the time. When I buy things, I pay tax. If I go to a store and I purchase something, the tax I pay is the percentage tax rate times the purchase price. This is real life. So sales tax is the tax rate times the purchase price. And then once I know how much tax I pay, what do I do with it? I add it on to the purchase price to get the total price. Total price is the purchase price plus sales tax. So let's look at these real life examples. A gold and diamond bracelet sells for $1,800, $1,800. Find the total price if the sales tax rate is 6.5%. Okay, so I go into the jewelry store. I see this gold and diamond bracelet. For some reason, I say, I want to buy this for $1,800. Okay. They take it to the cash register. They ring it up. The tax rate is 6.5%. So we want to find the sales tax. 6.5% of 1,800 is 6.5% times 1,800. Tax rate times purchase price. 6.5%, decimal goes 2 places to the left. Decimal form of that is 0.065. 0.065 times 1,800, the calculator tells us, is $117. So not only are we buying this $1,800 bracelet, we have to pay $117 in tax. So what's the total price? We add them together. 1,800 plus 117 is $1,917. The total price for the bracelet, $1,917, 1917. Okay, so maybe a bracelet that costs nearly $2,000 isn't something you can relate to. That's a splurge purchase. What if you need to buy a car? This time, the information is given to us in a little bit different of a way. Instead of us finding the sales tax, we are given the sales tax. We want to find the tax rate. So let's let R represent the unknown sales tax rate. Recall that sales tax is the tax rate times the purchase price. Plugging things in, the sales tax is $1,665. The purchase price is $18,500. We want to solve the equation 1665 equals R times 18,500 for R. But take a look at this form. Did we need to remember sales tax equals tax rate times purchase price? That was an easy way to do it. But if we translate this into one of our percent equations, 1665 is what percent of 18,500? We wanted to find the sales tax rate, which is a percent. What percent? What percent of 1,800 is 1665? We could have just set it up using our percent equations. Either way, we end up with this. We need to get the R by itself. We need to undo multiplying by 18,500. So we divide both sides by 18,500. And we get R equals 0.09. Sales tax is always given. Sales tax rates are given as percentages. So we change this back to a percentage. The sales tax rate is 9%. Maybe you've had a job that uses commission, or maybe you're just familiar with how commission works. The commission on a sale equals your commission rate times the amount of your sales. A sales representative for Office Product Copier sold $47,632 worth of copy equipment last month. What is his commission for the month if he's paid a commission of 6.6% of his total sales for the month? So he gets paid a commission of 6.6% on the total sales. So we need to ask ourselves, 6.6% of 47,632 is what? Or we could just plug straight into commission equals commission rate times sales. Either way, we're going to come up with the equation C, or whatever variable you're using, equals 0.066, 6.6% as a decimal, times 47,632. The calculator tells us that is 3,143.712. Why do we need 3 places past the decimal point when money ends with 2 places past the decimal point? It's because we have to look at this third digit to see if we round up the second digit. It's 2. It's not 5 or greater. It does not round up. So $3,143.71 is his commission for the month. So we found the commission. Let's do an example where we get this information and we want to find the commission rate. A salesperson earns $645 for selling $4,300 worth of appliances. Find the commission rate. So we can plug into our commission equals commission rate times sales, letting R represent the unknown commission rate. Or we could look at this and we can say $645 is what percent of 4,300? 645 is what percent of 4,300? It's the same. We want to get R by itself. We want to undo multiplying by 4,300. We do that with dividing by 4,300. Divide both sides by 4,300. Calculator tells us 645 divided by 4,300 is 0.15. As a percent, that would be 15%. Discounts and sales price. Sale price. Again, we live in a society. We go shopping. And when we go shopping, we like sales. We know how sales work. The amount of a discount is the discount rate times the original price. And this is another typo. Don't copy this with a multiplication. This is subtraction. Sale price is the original price minus, not times, minus the amount of the discount. I'm going to fix that right now. You shouldn't even notice. Magic. Fixed. Sale price equals original price minus amount of discount. How did I know that was a mistake? Why didn't I just blindly trust what was on the slide? Again, it's because we live in a society and we shop and we like sales. And if I want to know what the sale price is, I would take the original price and I would subtract the amount of the discount. A $2,000 designer dress is on sale for 30% off. Find the discount and the sale price. So if it's 30% off, I want to know what 30% of 2,000 is. And notice when we plug into amount of discount equals discount rate times original price, it's exactly the same as asking what is 30% of 2000. To do the math, 30% becomes 0.3. 0.3 times 2000 is 600. So the amount of the discount is 600. So what's the sale price? 2000 minus 600. Which is 1400.